Hi guys, welcome back to another video. In this one we're going to be covering interpreting exponential equations. Before we do that, I just want to do a couple of review problems. So the first one says the value of a brand new truck bought new for $28,000 decreases at 9.5% each year. Write the exponential function. So remember that we covered exponential functions before, and exponential functions can be written in the following format. A, which is the y-intercept, which is the initial value, times b, which is the factor. And remember, for exponential growth, we would add, if we have the rate, then we would add that to 1. And if it's decay, then we would subtract it from 1. And then the factor has the power of x, whatever the domain is. So in this case, they do give us a rate. So r would be as a decimal 0.095. And since the car is losing value, right, it decreases in value, this is decay, so the factor would be 1 minus 0.095. And the A value is the initial value. The initial value that we started with in the car is 28,000. Now I'm going to go ahead and use my calculator here on the side to subtract quickly. And the factor is 0.905. Okay. So this exponential function would be f of x equals 28,000 times 0.905 to the power of x. Okay, let's move on to number 2. Number 2 says Maya's grandfather opened a savings account for her when she was born. He opened the account with $100 and did not add or take out any money after that. The money in the account grows at a rate of 4% each year. What is the growth factor for the account, and how much money will Maya have after 6 years? Okay, so remember that the growth factor, since this is growth, I will add to 1, and the rate as a decimal would be 0.04. So I will add that to 1. And that would be 1.04. So that is the growth factor. What you would multiply by is 1.04. Now, how much money will she have after 6 years? Well, the function here would be f of x equals what he initially put in, which was $100, times that growth factor, 1.04 to the power of x. How many ever years have passed? Since it is growing per year, so it's just one time per year that is being calculated. So in 6 years, we've calculated that interest 6 times. So f of 6, and I'll use again my calculator on the side here, would be 100 times 1.04 to the power of 6. If you're not using a scientific calculator, you would want to make sure that you do the exponent first and then multiply 100. Okay, because you remember, order of operations, you do exponents first. So we get $126.53. It's 126.531, whatever, but of course money, we're going to round to the nearest hundreds. So it's $126.53 after 6 years. Okay, so not a whole lot, but we didn't start with a whole lot either. All right, so in this lesson, I want to start first with covering the difference between simple interest and compound interest, because you covered simple interest before. Simple interest is just when you get interest paid on an investment and there is not an interest that you have received. So you just get interest paid a certain amount on a certain amount of money and not on any interest that you are paid as well. Okay, so in a compound interest situation, you get interest paid on both your initial investment and on any interest that you have earned over time. So in order for me to explain this even better, I have the two example questions here, okay? So imagine you deposit $1,000, okay, and you get paid 5% interest each year, okay? So in a simple interest, you're just being paid 5% on that $1,000. So 5% of $1,000, okay, 0.05 times $1,000, it would be $50. So you're getting $50, right? Now, the first year, you have the $1,000 and the $50 that they paid you for interest, so you have $1,050. On the second year, let's assume you did not put in any money, did not take any money out. How much are you paid? 5% on that $1,000. You get another $50. Now, on the second year, we're up to $1,100. Moving on from there, on the third year, haven't put any money in, haven't taken any money out. What do we get? We get 5% on that $1,000. We get another $50. So now, after 3 years, we're up to $1,150. Now, what happens in the compound interest situation? Well, let's say you take that same $1,000 and you put it in an account, but this interest is being paid 5% and it's being compounded annually, okay? So you are getting money on not only the $1,000, but whatever is the remaining balance on the account after that year. So the first year, it's the same because we get $1,000, 5% of that $1,000 would be $50. So we are at $1,050. So far, no difference. Now here's where the difference comes in. On the second year, you're not just getting paid 5% on the initial investment that you made, you're making 5% of whatever is in the balance of the account, whatever is the balance of the account, which is $1,050. So you're not only making 5% of the 1,000, you're making 5% of the $1,050. So you're actually making $52.50. So if we add that to the existing balance that we had in the account, we are now at $1,102.50. So not a huge difference from before. Let's look at what happens in year 3. In year 3, we're making 5%. Now again, we're not making 5% of what we initially invested. We're making 5% of whatever the closing balance was. So we are making a 5% on that amount, $1,102.50. So let's see what that is. Okay, $55.13, right? So now we made an extra $5 over what was in year 3 for simple interest, which was just $50. So we're going to go ahead and add that to our previous year's balance. And so at the end of year 3, we have $1,157.63. Now, you might be saying, okay, well, that doesn't make a huge difference, right? We're at the end of year 3, we're at $7 difference from before. But the important thing to note about compound interest is that the more time that passes, the quicker that money will grow. If you notice, at first we had no difference. Then we had about $2 difference. Then we had a $7 difference, roughly, right? And if we keep going, you'll see that that compound interest, that money will grow exponentially. And that is why compound interest is an exponential growth problem. So, simple interest, this is what it is. I just put it here for you guys to just recall it from Algebra 1. This is not what we're talking about. Simple interest is linear. Compound interest is exponential. With simple interest, you're only being paid on your initial investment, not on any interest that you have received in that account. Versus compound interest, you get money paid on both. So you get paid on whatever is that ending balance. All right, so let's move on. Okay, so again, a very common situation that we can model with exponential functions is compound interest. So again, what is compound interest? Compound interest is interest that is added not only just to your initial investment, but to the principal of a deposit. So that means that you're also earning interest on interest. Okay, so consider this compound interest situation that we have here. Now notice that this is very similar to the equation that we covered before. But before, we just looked at R, right, as whatever the rate was. And we didn't take into consideration how many times we were going to calculate the interest, right? We just kind of fiddled with it with the amount of times, with T. But that also wasn't strictly money problems. This compound interest is strictly talking about money, how much money you're making on an account. So this is the compound interest equation here, okay? P is the principal amount. That's whatever amount of money you put in at the beginning. And then 1, of course, is just 1. R is still our rate, and we still need that in decimals. What we're going to do with the rate, though, is we are going to divide that by n. We're going to divide it by the amount of times that you are going to compound that interest is being calculated per year. And then in the power, not only do we have t, which t is strictly because we're talking about money here, it's going to be in years, but we're also going to multiply t by n. How many times we are compounding it in the year. So notice I put here on the side, because you might not know these words, right? Annually just means 1 time per year. Semi-annually means 2 times in the year. Quarterly means 4 times in the year. Monthly would be 12 times in the year. Weekly would be 52 times in the year. And then daily is 365 times in the year. So let's take a look at these two questions here. You put $1,000 in an account with an interest rate of 8%. This is compounded quarterly, so 4 times in the year. How much money will you have after 5 years? Okay, remember again, the equation is A of t, the amount of money that you have in t years, is P, whatever you initially put into that account, times 1 plus R, whatever the rate is, divided by N, the number of times that it is calculated in the year, to the power of N, the number of times that it is calculated in the year, times T. How many ever years have passed? So our principal amount would be 1,000, so P is 1,000. Our rate is 8%, so R is 0.08. And N would be 4, since this is quarterly, it's 4 times in the year. And then they ask us about a specific question. Let's just go ahead and write the equation for this situation. So we have A of t equals 1,000 times 1 plus 0.08 divided by 4 to the power of 4 times t, okay? Now, you can't leave it like that, okay? You have to simplify on the inside if you're writing the equation for the graph. So I'm going to go ahead and just simplify the parentheses there, 0.08 divided by 4. Of course, I would divide first and then add 1, but I'm using a scientific calculator, so it'll do the whole thing for me. So I have 1.02. So obviously they asked me a specific question, but if they just asked me for the equation for this function, I would just have to simplify the inside, and that would be 1.02. So this is the equation or the function that represents this situation. Now, of course, they did ask me specifically how much money you are going to have after 5 years. So how many years have passed? It would be 5. So we're finding A of 5. Remember, in these questions, you are looking at specifically Y is, or T, I'm sorry, is how many years. So we are just plugging in 5 for T. Okay. So I'm going to go ahead and obviously 4 times 5 is 20. So I'm going to plug that into my calculator. 1,000. Oops, I think I put one too many zeros there. too many zeros. 1,000 times 1.02 to the power of 20. And that would be 1,485 and 95 cents. That's how much money I would have after 5 years. All right, let's look at number 2. What was the amount deposited in an account compounded monthly for 5 years at a rate of 3.25%? If after 5 years you have $5,300. Okay, so this is a little different, right? We don't know. What we actually don't know is the initial amount that was deposited. So the amount that was deposited into the account, we don't know that. That's our unknown, P. Now, we do have that this was compounded monthly, so N is 12. And we do know the time, T is 5. And we also know the rate as a decimal, 0.0325. Of course, 5 years, we already know that the time is 5 years, but we know the amount that we have after it, right? Which is A of T. We know the output, A of 5, I should say. After 5 years, we had $5,300. So, what's the equation? Well, the output, how much money I had in the account was $5,300. The principal amount is what I don't know, so that'll be my variable. And then I have 1 plus the rate was 0.0325. N, the number of times that it was calculated in the year, was 12. And then to the power of N, which is 12, times T, which was 5. So now I can go ahead and simplify. Actually, let me simplify inside of here first. So I have 5,300 equals P times, and then let me just simplify inside. 1 plus, and then in fraction, numerator 0.0325, denominator 12. So we get 1.0027008333. Okay. I do want a very exact answer. So I'm going to just write down 1.0027. Usually 4 decimal points is good enough. It would be even better to leave that there. Now I need to put that number to the power of 12 times 5. Now 12 times 5, I know, is 60. So now I can do on the calculator, I can leave that decimal there, and I can, which is obviously more precise than if I just had 4 decimal points. I have the entire number there, the whole thing, exactly what it is, and now I can put it to the power of 60, which will be a more exact answer, which will be a more exact number. So now, I will have that number there, okay, which is 5,300 equals P times 1.0, or actually, I'm sorry, we just did that, so that ended up being what? About 1.1762. Okay. And then, of course, to solve for P and this number are multiplying, so I will divide by that number. Now, again, if you want to have the most exact answer, you will not round it. You will leave it in your calculator exactly as it is. So we end up with P equals, and of course you can divide that. You'll get a good enough answer. You will get a close enough answer for you to figure out the correct answer, but I want to be really precise. So what I'm actually going to do is I'm going to go back to this number, and what I'm going to do is I'm going to take that number, put it to the power of 60. Actually, I already did that. I'm so sorry. Let's clear that. Okay. So I have that number to the power of 60. So this is the number that I want to divide by. So I'm going to do 5,300 divided by, and I'm going to press second and hit answer. That way I am dividing 5,300 by not the rounded version of this, but the entire version of this. So that'll be a more exact answer. So we end up with $4,506.07. And that's what we initially put in the account, the initial investment. Okay. Now, just for the sake of showing you what would happen, right? What if we did 5,300 and we divided it by the 1.1762 instead? Very similar. We're 0.04 off. We're 4 cents off. It's okay. You'll be able to find the correct answer, or if yours is, it's rounded and you're a few cents off, I'll be able to tell that you were following the correct work and whatnot. So it's okay if you're a little off because of rounding. All right, so go ahead and pause this video now and try number 3 on your own. All right, so this one says you deposit this amount of money in your savings account. Okay, so that is the initial amount. P is 4,200. That has a rate of 9%, so R is 0.09. The interest is compounded monthly, so N is 12. How much money will you have after 10 years? So how many years have passed? 10. We have the second question. I thought for a second I'm like, is that a duplicate question? No, the second question is asking how much interest. So first we want to see how much money you're going to have, and then they want to know specifically how much interest, which interest is amount money that wasn't your own, that was paid to you for keeping that money in the account, right? So let's go ahead and write our equation. So A of t, the amount that you have depending on t years, will be 4,200 times 1 plus 0.09 divided by n, which is 12, to the power of n, which is 12, times t. I'm going to leave t blank for now just so we could write the equation for this situation first. So again, simplify what's on the inside. So 1 plus 0.09 over 12 is 1.0075. So the equation would be, let me write this down before I forget, 1.0075. It would be 4,200 times 1.0075 to the power of 12t. And that will be the general function rule for the situation. Now, specifically talking about the question that they're asking us is how much money are you going to have after specifically 10 years? So now let's plug in t is 10. So A of 10 would be 4,200 times 1.0075 to the power of 12 times 10. Now 12 times 10 is 120, so I'm going to take that and put it to the power of 120, and we get that number, and then that we need to multiply, excuse me, oops, I didn't mean to click that, and then that number we need to multiply by 4,200. Oops, I just wrote 4,200 when I meant to say multiply by 4,200. Okay, so we have $10,295.70. $10,295.70. This is how much money is in the account. We'll say money in account. Now the second question asks how much interest you're going to have after those 10 years. So we've already calculated how much money we have total. Of course, not all that money was given to us by interest. Some of that we had put in ourselves. So to find the interest, we take how much money is in the account and subtract the amount of money that we initially put in the account. So I'm going to take that amount of money and subtract 4,200 which is why I initially deposited into the account. And we have $6,095.70. So this is how much interest was paid to me. So this is, we can think of it like free money for initially putting some money in an account and leaving it there. Okay, so that's how much was paid in interest. This is how much in the account is at the end total, of course, including the initial amount that we put in ourselves. All right, so hopefully this was a little bit clearer for you with exponential growth and specifically compound interest problems. I will see you guys in the next video. Bye.